All right, so in the last video, I talked about the zeros, and that's what happens kind of in the interior of a polynomials graph. But in this video, I want you to zoom out and just look at the end behavior. So I'm not going to worry about where it hits the x-axis, where it hits the y-axis. I'm not going to really worry about what sort of curves or wiggles happen in the middle. All I'm going to worry about is what happens when I zoom really far out and I look at the two ends of the graph. So let's start with I'm just going to throw some things in here and see what happens. Okay, so when I look at this polynomial right here, let's zoom out. You see there's some wiggly stuff in the middle. It gets really, really steep. I'm going to adjust my x-axis so I can only really look from like -50 up to +50. I'm going to make my y-axis go up really big. Okay. That's weird. What did I type wrong? The x-axis goes from -50 to +50. There we go. So, I can even zoom out a little bit more. All right, so I don't care about all of this wiggly stuff in the middle. I am ignoring this. We could figure that out, but we don't care. All I care about is the ends. And what I see is that this end is going up and to the left, and this end is going up and to the right. So what that means is the further that I go to the right, the further that my graph goes up, and the further that I go to the left, the further that my graph goes up. So how do you describe that? What you say is, as x goes to the right, approaches positive infinity. I want you to think about the number line, the x-axis. If you go really far to the right, you're approaching infinity. So this is the compact math way of saying that. You're saying, as x approaches infinity, what happens? The y value also approaches infinity. Then you're not done. You just talked about one end of the graph. The graph has two ends. It also goes to the left. So how can we describe going to the left? As x approaches negative infinity, y approaches positive infinity. So let me put that in just plain English. This sentence right here is saying, as you go right, the graph goes up. And then this other sentence is saying, as you go left, the graph goes up. I'm okay with you using plain language. I just want you to also see how this really compact notation right here, this is probably the shortest way that you can describe the end behavior. And make sure you're giving me both ends. You got to give me both sides of it. All right, let's modify this graph a little bit and talk about how the end behavior changed. Let's make this one, instead of just an x, let's make this into an x squared. All right, so now we have a different situation. We have, instead of it going up on both ends, it's doing something a little bit different. So let's bring our x's in a little bit. We really only need to go from -50 to 50. And let's make our y's get even bigger. Let's throw some more zeros on there, on both ends. All right, so again, I am not looking at the interior in this video. We're ignoring this. Don't worry about that. What I am looking at is the fact that as I go to the right, I go up, and as I go to the left, I go down. So as I go to the right, I also go up. As I go to the left, I go down. So think about how I said that out loud while I was writing it with the math notation. I'll say this one again. As I go to the right, I go up. Then this one in the bottom left. As I go to the left, I go down. Okay? Now, how are you supposed to know that if you don't have the graph? What you do is you look at two things. You look at the degree and you look at whether it is a positive or negative leading term. This one right here has a degree of 5. Why 5? I have 1, 2, 3, 4, 5. I'm counting up how many x's there are when I multiply them. This one also has a positive leading term. All the x's are positive. There's no negative in front of the x's. So it's a positive leading term. Some people will say leading coefficient. If I have an odd degree and a positive leading term, I'm going to see something that goes from low to high. Let's see what happens if I put a negative in front of it. So I'm going to copy this same graph, paste it down here, put a -3 in front of it. The ends switched. Look at that. So now, let's add that to our notes here, that if I have an odd with a negative leading term, now my graph starts high, ends low. Well, that's for odd degrees. Let's make it into an even degree. Let's put an x plus 2 on there. Let's put it on both of them. So we'll look at the red one first. When it's an even degree, I hope you can see how it's pointing up on both sides. Let me adjust those x's in one more time. There we go. You can see it's going up on both sides. So when I have an even degree and a positive leading term, it's going up on both sides. It might be doing some wiggly stuff in the middle. When I change that and I look at instead even degree with a negative leading coefficient, points down on both sides. Okay, and those are the only 4 possibilities. Count what the degree is, check if the leading term, the leading coefficient, is positive or negative. I want you to notice that if the degree is even, then it's even on both sides, both up or both down. If it's odd, it's 1 up, 1 down. You just have to check what direction it's going. I want you to also notice that if the leading term is positive, it's going to end up and to the right, because positive numbers for x and y go up and to the right. And if it's negative, it's going to go down and to the right, because that's where the negative y values are. So, thanks for watching. Please let me know if you have any questions. Happy to help.